Can you hear me? Oh, it's very loud. So this talk is about both the PHP and how every single programming language on this planet works, basically. So before I start, my name is Joe. It's not an actual name, but it's a fake name I chose. Same thing as Slash from the Guns N' Roses, I guess. I live in New York, which is pretty far away from here. So I'm a little bit jet lagged, but I think we should be good. I also happen to be a huge fan of Japan, so if anyone has a GTR I can just take for a spin, I'll take on that. This is out in New York. Okay, so this talk is about this. What happens in your machine, in your server, in your laptop when you run PHP, hello world PHP? Because you're clearly not compiling PHP. You're not getting an executable, but yet somehow the program gets executed, you get an output, or the web browser spits out something out of it. So I kind of looked at it and I was like, I don't really know how this is working. So let's look at C, how C does that. In C++, of course, you first compile the program, and then once you have an executable, you can either run it, or you can, I guess, deploy it to a server, you can install it on a machine. So there's two steps. There's the compilation step and the execution step. PHP doesn't seem to have it. I was like, how does it really then work? So my choice was I can just start reading books. And there's a lot of books about programming languages. There's a lot of courses you can take at universities which kind of try to teach you how programming languages get compiled, how they get executed. If you took at least one class in a university about programming languages, you probably played around with Lisp or implementing a Lisp compiler because it's probably one of the easiest languages to implement. Yet I really wanted to understand PHP, so it wasn't good enough. So as a hacker, I was like, what's the easiest way to do it? Write my own compiler. So there's a saying, everyone should write their own framework and then never use it again. I kind of applied the same logic for the compilers. I was like, everyone should write a PHP compiler and then never use it again. Some people end up creating successful competitive compilers like Hack or HHVM from Facebook. But for my case, I just did a play around project. So it's called PyHP. All of the source code is available on GitHub. Of course, it's extremely, extremely basic, and don't ever try to run any production loads on it. I don't think anything will work. Yet, it implements the basic fundamentals of PHP. So how does it work? Well, as the name suggests, there's both Python and PHP involved. It uses Python to implement the actual interpreter and the compiler, and then obviously it runs PHP code. Compilers are somewhat complicated pieces of code purely because of how much time it takes to implement all the different features and all the different PHP bugs as well. So it doesn't support the full subset of PHP functionality, just the sheer amount of work it would take. I couldn't do it. But it definitely supports the basics. It supports the kind of PHP 4 minus the classes. So PHP 4 minus all the useful parts, you could say. And it's extremely, extremely fast. If you think PHP 7 is fast, if you think HHVM is fast, PyHP is at least 3 times faster than PHP 7. And we will see why. And the nice thing about PyHP and what makes it really unique is that it's the only existing PHP 6 implementation on the planet. So what does PHP 6 mean? If you run this code, this little 3-line code, in any PHP version, you will get 2 question marks because you're trying to access 2 characters in a Unicode string. The strings, of course, in PHP are not Unicode. They're byte-based. So PHP, of course, fails. It kind of prints 2 parts of a Japanese character. With PyHP, though, it does everything correctly. So if you run the same code with PyHP, it outputs the separate characters. And that's what PHP 6 tried to achieve, but it kind of failed because it's just too difficult. PyHP, luckily, actually does that. So if you ever need Unicode on a language level, maybe PyHP is the right thing. We'll come back to that. But now I want to talk about how I kind of implemented PyHP and how PHP itself actually works. So if you look at any programming language, PHP, Ruby, Python, any dynamic programming language, they all have 3 steps in the execution pipeline. First of all, you parse the file. So you just take the source code, a bunch of, like just a massive list of strings, and you parse them. Then you, it's supposed to say compile to bytecode. Then you generate bytecode out of the parse source code, and then you can execute the bytecode. So if you use opcode cache, or I hope all of you use opcode cache for PHP, the question is, how does it work? It works actually super simply, because what opcode cache does, it caches the result of those first 2 steps. So it parses the file, it generates a bytecode, which is in some way a representation of your code in this virtual assembler language, and it caches that on a file or on memory. So the next time you try to run the same sort of a PHP file, it doesn't have to do that again. It can just go straight to execution. So that's the first lesson. How does opcode cache work? It caches the first 2 steps of execution. It's very, very simple. So what does parsing mean? Well, parsing is a very simple operation. What we're trying to achieve is we're trying to turn your source code, which is just like a massive string of text, into something we can like play around as a data structure. Which means we are trying to turn your source code into a tree structure of different code blocks. If you go to the GitHub repository for PHP itself, you can actually look up the Zen language parser Y file, and there's just a massive long list of rules of how PHP is supposed to work. And then from that, we can parse that. PHP 7 also introduced a second step where it takes the parsed kind of array of tokens, and it turns that into a tree structure. And once you have a tree structure, you can do a lot of computations on a language level. So how does grammar look like? This is just an excerpt of how PyHP grammar is defined. So if you look at it, it's very, very simple. But it's kind of a recursive language, so it can be parsed very, very fast. If you look at the if statement, it's kind of self-explanatory. You have if, then you have a comparison expression, and then a statement, or you can have a comparison expression, a statement, and an else branch. What is a statement? Well, a statement can be a code block, can be an assignment, can be an if statement, can be a return statement. And then what is an assignment operation? There is a variable equals something, or a variable equals a literal, which is a string, a number, a float, an array, or something like that. So that's how languages get defined, and that's how they get parsed very, very quickly. How does PHP work like that? Well, if you have this piece of code, which is a string assignment, there's a feature, there's a function in PHP called token_get_all, which outputs all the tokens of the actual source code. So if you run that, that's what you get. For every line of code, for every piece of code you have, there's a token, there's the code representing the token, and the line number. That's how the first step of parsing the language. Once you have that, then you can have a nicer structure, because from a list of tokens, then you can just turn that into they're called ASTs, into a street structure of code. So now we went from your code being just a nice piece of text into an actual nested structure we can then use later. That's the first step. Now we're talking about upcodes. The easiest way to explain what upcodes are is that there are virtual assembler commands. If you tried writing assembler, which I kind of feel sorry for you, if you tried writing assembler, bytecode and upcodes are kind of the same thing, yet they work, instead of assembler working on a machine level, opcodes and bytecode works on a virtual machine the Zen Engine virtual machine. So the code gets represented as just a massive list of these virtual assembler commands, which then can be used for execution. And the kind of a fundamental point of this is that the code becomes flat. So instead of having functions, instead of having if statements with branches, instead of having loops, opcodes and bytecode is just a sequential flat list. There's no branching at all. It's all implemented using labels and jumps. In PHP 4, if you've been doing PHP for long enough, if you ever use these things called PHP optimizers, even before opcode cache was around, optimizers, what they would do is look through these opcodes and try to find ways to optimize the code. Because that's the easiest way to implement these kind of language level optimizations, because opcode has no relation to your actual code. So your structure is gone, it's just a nice little list. So optimizers used to play around with opcodes. And there's an extension you can install for PHP called VLD, which will actually spit out all these opcodes. Let's, again, look at the same code example. The same code, hello world, assign it to string, print the string. If you use this VLD extension and try to look up all the opcodes, this is my code that are presented in the kind of virtual assembler for Zen Engine. It's very self-explanatory. I have an assign command, and then I'm assigning a hello world string to the 0th variable, and then I'm printing that 0th variable. And the third step is I'm doing some cleanup. I'm just removing the result from memory. This is what opcodes cache. This is what opcode is. Opcodes are, and that's what gets stored in cache. Of course, not in a string form, in a binary form, but ultimately that's what they are. And once we have this, then we can just create a kind of an array, a list of a bunch of instances, and bytecode ultimately looks like this. So when PyHP does bytecode generation, when PHP core itself, when HHVM, any implementation for any language ends up having this. The end result is just an array of opcodes. But we can go do something more interesting. So remember we talked about how there's no more structure in your code and the branching is gone, so it's just a flat structure. Here I have the same sort of code, but instead of printing it, I have an if statement. And you can see in this massive list of opcodes, all of a sudden there's no branches. How does it work? Well, I have color highlighting, which showcases that. So the first statement, the if statement, is these two opcodes where I'm checking if the variables are equal, and if they're not, I'm doing a jump. But if the code doesn't jump, because it's executed sequentially, if the code doesn't jump, it prints, it frees a variable, and then jumps back here. Or if this is else, it jumps to here, executes for this. So you see, by using jumps, and I'll share the slides so you can actually look at the actual commands. By using jumps, we can implement branching in a sequential manner, because I'm going through these lines one by one instead of in case, yeah. And then we get to the final point. How do we execute this? We went from parsing the code to getting a list of bytecodes. Now it's the final step in execution. In PHP, that's handled by what's known as the Zen Engine, the fundamental part of the PHP core. Zen Engine is a virtual machine which runs your bytecode. Again, the same comparison. You have assembler, which runs on machines, and you have opcodes and bytecode, which runs on virtual machines. So as the code is running, Zen Engine is managing the memory. Zen Engine is managing the actual machine level commands. The bytecode just doesn't care about system level stuff. This is how it looks like. So to reiterate, we first parsed the file, we got an AST tree out of it. Then we turned the AST tree to a bunch of bytecodes. Again, the same sort of structure. Now you're just losing nested sets. And now we can actually execute the code. With these 3 steps, we can execute. This is ultimately what PHP is all about, and this is ultimately what Ruby is all about. A compiler for a dynamic language pretty much looks like this, plus a million lines of C code. But it kind of looks like this. And what it does is it loops through every single bytecode element in your list and executes every single opcode just one by one. And if that handler returns a result, it returns from execution. If it returns a jump, it jumps to whatever the opcode is saying. And if not, it just keeps running through the list. Like, I'm not kidding. Every single language has this sort of loop somewhere in the code. And then when it comes to handlers, they're super simple. All the handler gets is the VM saying, this is the current frame, so this is the current memory, these are the current variables in there. What do you want to do with it? And for example, when it comes to assign, of course, I'm getting whatever the result is on top of a stack, and I'm storing it with the variable name I have. When it comes to returning the variable, I'm doing almost exactly the same thing. Just instead of assigning the variable to something, I'm getting the value and returning it back to the execution point. It gets a bit more interesting because when it comes to calling functions, because we lost the structure, how do you call the function? Well, the functions get called by first creating a new memory frame, because inside of a function, I can't access the variables outside of a scope. So we introduce scoping. So that's why we create a new frame, yet we give it the parent frame. So if we need to access global variables, we can still do it. And then we just call the same interpreter with this. If you ever ran into problems where PHP throws an exception saying max nested level has been reached, which is usually 100, it's complaining about that because in function calls, even on the compiler level and execution level, it keeps having to go deeper and deeper into execution, keeps having to create these new frames. So if PHP just allowed you to call the same function from a function itself recursively 1,000 times, there would be 1,000 frames, like the parent nesting up to 9999. That's why languages don't allow you to call recursively so much. That's why you sometimes would read recursion is not the fastest way to do things, because recursion allows you to create new scopes. That's kind of the optimization thing happening. And of course, the reason why people do these sort of things, the main reason why people do compilers and are trying to reinvent these sort of things is, of course, performance. Why else would you spend all this time trying to figure out how to implement a compiler if not to optimize for performance, trying to improve the performance of PHP and other languages? And why do people do it? Well, because some people say PHP is slow. And you could say that PHP is slow, but you can only say if you're comparing it to, say, to C, which of course is a much faster language. Or, I don't know, to C++. Any low-level language, of course, is going to be faster. And I was thinking about this, I had a question like, why actually PHP is slower than C? What makes C so much faster than PHP? Like, why can't PHP just be as fast as C? It's a kind of a brain teaser. And the reason why C is so much faster is because it's very specialized. What does that mean? Well, PHP is a very kind of abstract language. There's no variable types. You can access anything you want. You can even use eval and all these statements. So it's not specialized. In C, it's almost as close to machine level as most people will get. You're explicitly defining every variable. You're explicitly defining everything. And that's what makes the code specialized. So to reiterate, C is faster because it's specialized. PHP is not as fast as C because it's not specialized. It's a very generic language. And of course, statements like eval kind of prevent PHP from being even more faster, because to support eval, you have to support very dynamic things. And now, having tried to implement my own compiler, I still have no idea how to implement eval, because I have to parse strings as I'm executing the actual code, and like scopes and all this stuff. Pretty difficult. So how do we achieve C-level performance for PHP, for a language which is not specialized? Well, there are interesting tricks on hand. You can achieve specialization automatically. It's called JIT. What's different from JIT and what, I guess, C uses is that in JIT, the code itself optimizes itself as it's running. If you ever played with the Facebook HHVM, the PHP interpreter, it uses JIT. Every single .NET, every single Java implementation uses JIT. Most Ruby implementations use JIT. Most languages use JIT. PHP will probably use JIT at some point in the future. What JIT allows you to do is to write unspecialized code, very vague, very open, very abstract, but then make the compiler optimize it for you as it's running it. So as a developer, you're not spending all this time specializing on data types and doing all that kind of stuff, and then the compiler figures out how to do it. How does it look like? Here's an example. So here's an example of one of the functions in the PHP bench file. It runs 2 loops, and all of them it runs for 1,000,000 times. How can we optimize this? Well, as a developer in PHP, there's nothing you can do. Like, that's as optimized as it probably will get. Maybe you can try to use shorter variable names or something like that. It probably won't improve the performance. But in a JIT environment, in an HHVM environment, the code gets executed on runtime. How does it do that? Well, the compiler can detect that you're calling the same thing over and over again. Because this loop runs 1,000,000 times, and the compiler doesn't have to check these conditions at the top every single time. It knows that the loop will run 1,000,000 times because the variable says it's a 1,000,000 time condition. So the compiler itself knows about your code and can actually run it so much more faster. And the nice thing about it, even though I'm not defining any types anymore, like on execution, it knows that they're all integers. It doesn't need to check for variable types. You don't have to define them. But by just running your code, it knows they're all integers. So all of a sudden, these function calls where I'm increasing the variables by 1, where I'm doing checks, they can all be compiled to like C-level integers. And we are done with PHP type juggling, and super fast. So purely by running this code, we can make it super, super fast. We can make it C-level fast. And that's what HHVM does. That's what PyHP does as well. So to put everything back into perspective, coming back to PyHP, it uses the Python libraries. It's written in Python. It's fully unit tested. It can be run just as a normal Python program. It takes around 10 minutes if you want to generate the fast, optimized, like super crazy fast JIT compiler. If you don't, you can just run unit tests. You can play around with it as it's a normal Python program. Why did I do it? The main reason is I don't want to spend my nighttime playing with C code. It doesn't sound like fun. So I was like, I should just do it in Python, which is much easier. Getting into PHP core development, I wish it was a little bit easier. Because I'm doing it for fun, not to actually achieve any production performance, because I'm doing it for fun, I just couldn't spend the time to try and understand how the PHP core works. So I did my own project, and now I can actually understand how they both work. So the things to try, things to take away. There's a PHP compiler written in PHP. So you can run your code with a compiler written in PHP, which runs on the actual PHP core. That's the first link. So if you actually want to play around and want to extend the PHP language, that's the easiest one to get into, and you can see how compilers work. There is mine, which is just almost the same thing, just a little bit faster, written in Python. Again, you can play around with it, see how it works. And then there is HHVM. So if you want to achieve good performance, if you want to use JIT in production, HHVM by Facebook is the best project. It's written in C++, so it's a bit harder to understand. It's still pretty damn cool. Let me get some coffee. One more thing. There's something coming. What's next? So I talked about implementing this PyHP compiler, which written in Python runs runs PHP code. And the thing I learned about compilers is that the interpreter is the part which does the machine code generation. So as the PHP code is being run, it generates the machine code as it needs. Well, the question then comes, can it only generate machine code, but could it also generate something else? Yes. It's called PyHP.js, and it's not a fucking joke, it's real. What it is, it's a Python compiler. It's a compiler written in Python, which compiles itself to JavaScript, which you then can use on a browser to run your PHP code. It's insane. But it actually is a real thing. So I have my PyHP compiler, which is a JavaScript program, being run by a Node.js. Node.js is just the Google's server-side JavaScript engine. I'm running my bench file through that. So there is a PHP file, which is a bench file. I'm running it through a compiler which is written in Python, then compiled to C, then compiled to machine code, then compiled to JavaScript on a JavaScript VM. It's pretty damn impressive and completely useless. And if you find this funny, there's this talk called The Birth and Death of JavaScript, and he talks about running GIMP and other programs and like Unreal Engine in browsers. And that's what I did the same. It's just a play with technology of I can run my code on a browser. It's not translating my PHP code to JavaScript. It's not like cross-compiling PHP to look like it was JavaScript. It's actually running a PHP VM on a browser with memory management, with output buffering, all the things, as if PHP was running on just a PHP itself, but it runs on a browser. Maybe one day you can actually write your apps for phones in PHP. And I'll be the first one who said it's possible. Does anyone have any questions? Or maybe you can, I don't think we have time. Maybe you should tweet me the questions, and I can answer you in whatever that is. Technology. And yeah, tweet me the questions. If you want to check it out, I have for both PyHP and PyHP.js, they both have Docker containers configured. So if you want to play around with it, you can just go to GitHub and find these projects and actually run them. And fingers crossed, they will work. The JavaScript one is very buggy, but the non-JavaScript one, the Python one, will run just fine. So if you want to learn about languages and you want to learn about how PHP actually works as a language, as a programming language, so it's not just a black box, you just throw code and something happens, yeah, play around with it. Thank you.
海外ゲスト、ジョー様によるご講演でした。ありがとうございました。